Hello, how are you guys? Excellent. Thank you for bearing with us. I had a small microphone problem. Wasn't my problem. Oh, okay, name joke. My name is Michael View. I work alongside Kevin at Sickage. We're here to talk today about making a thing, creating professional quality embedded devices. So a little bit about ourselves. Like I said, my name is Michael View. I work as a penetration tester at an organization called Sickage, formerly 403 Labs, if you've ever heard that name. I'm also an adjunct professor at a college in my town where I live, Milwaukee School of Engineering. We do a lot of hardware hacking on the side just for fun. Also work on the Mini Pointer project. I don't know if anyone's familiar with that particular Dropbox. Kevin was a creator. I'm now the maintainer, I guess we'll call it. And Kevin and I together both kind of founded the Mayhem Lab project.
I'm Kevin Bong. If the mic cuts out or we're getting like this, wave your hands in the back so we know. Everything Michael said, and then we've done a lot of these hardware hacking talks. Really, neither of us have a background in electrical engineering, circuit design, things like that. This has all been stuff we've learned just like, by the seat of our pants pretty much. And that's what we're trying to share really is, when I got started in this, it seemed like hardware hacking was very intimidating. Like you need equipment, it's expensive, there's a lot of knowledge you need and things like that. And what we learned is it's really not the truth, especially nowadays, and we'll see a lot of that in the talk. So really what this is about is to get people interested, to see that it's not that hard, it's not that expensive, to get involved in doing this stuff yourself.
So a little bit about Sickage, since they're paying us to be here today for this conference, which is a fantastic opportunity. We at Sickage are a full-service IT consulting firm in general, actually. We do information technology, but also HR-related stuff, tax, human resources, pretty much any consulting that you might possibly need. Sickage is sort of a one-stop shop. As Kevin and I have already mentioned, we work in the security and compliance area, where we focus mainly on PCI-style assessments, but we do a lot of other penetration tests and hardware hacking as well. So quick agenda for today, because you always need one of these. We're going to talk about, kind of walk you through the process of how we developed the product that we came up with. First things first, we always have to have an idea, right? What do we want to make? Then we're going to talk a little bit about circuit design, how we actually went about prototyping it and designing this thing, and then of course assembly. So this is kind of how our workday works. I'm sitting at my desk. Kevin walks in. And he says, "Hey, I have an idea." Okay. He says, "Hey, I want to buy chicken nuggets from some place with a sonic screwdriver." I'm like, "All right, that sounds neat, because who doesn't want to do that, right? Walk into a store and pay for something with a sonic screwdriver." So we're like, "But how do we do that, right?" So real quick. To keep it short, this is the product that we actually came up with. I keep saying product, it's not. It's a Meg spoofer, open source. It's a small little handheld device based on the Arduino. This is what we're basically going to be talking about today, how we ended up making this thing. And just to prove that it actually does work, it stores up to 5 different credit cards and basically mimics Apple Pay or Samsung Pay through EM fields. So that's kind of what we're going to talk about, is how we came up with this device. So of course we started, just like anybody else, we asked Google, right? How do we do this thing? So if anyone's familiar with Sammy, has anyone seen Sammy's talk? He's sort of the founder, creator of the Make Spoofer. So we kind of stole his idea and morphed it a little bit. Excellent individual. We've got his information up here on the slide, so take a look at his presentation that he gave. I think it was at DerbyCon 2 years ago? Yeah, not this year, last year. But we decided, so we started looking at his presentation and thinking, wow, we need to learn a lot of different things here. So how do we go ahead and build stuff? Because we've both soldered things before, we've done through-hole design, but how do we actually kind of take this to the next level? We want to make a nice looking product. A big hurdle for us was the surface mount soldering, which we'll talk about today, how we kind of overcame that in a relatively reasonable budget. And then also antenna design. We went through a lot of different iterations, and happy to talk about it here, or if you want to catch us around the conference, we're got a variation of the different prototypes that we did, so happy to share those with you guys.
And as Michael said, we started with the original mag spoofer. It was just a more research project that this individual had done. The mag spoofer is pretty simple. You're just creating an electromagnet that oscillates its field in the same manner as the electromagnetic field would oscillate when you slide a credit card. So it seems like a pretty simple thing, but there's a lot of parts that we had to kind of come up with to build what we thought would be kind of a fully featured product around, or a fully featured device around that kind of basic fundamental idea. So we thought, well, we want to add Bluetooth communication because we want to be able to, on our phone, add new credit cards or select which credit card we want to use when we click the device. We have to figure out how we have different controls to, click a button, have it send a card number or something. Had to learn about power regulation, so we want to put a battery on this so it can be in our pocket. And just, what is the best way to get a really strong antenna field? Because like I said, I wanted to walk into someplace and, use my sonic screwdriver on the payment terminal, but kind of do it discreetly so that people aren't asking what I'm doing. So you need a little bit of distance, you need a pretty strong antenna as well, is what we came up with. And so the first step of the circuit design was really each of those goals. Okay, we've got a goal for power regulation. You go out on the internet and say, okay, what's a good power regulation circuit for, in this case, we're using an Arduino-based circuit. So what's a good power regulation circuit for that? What components do I need? And you find, you might find diagrams like this one that shows the power regulator and the few different components you need for that. What's the best way to drive this magnetic coil that we've built? Well, it turns out that coil is just like the coil that you'd find in a stepper motor. So what we actually use is it's called an H-bridge, but it's something used to drive, well, not necessarily stepper motors, but used to drive motors. We're just driving magnetic coil like we would a motor. And then there's the Bluetooth module down here. Those are available off the shelf. And so, how does that connect to the Arduino? So really, again, first step was getting a working version of every single individual component, and then starting to put that together.
So of course, before we started had to build things, we need stuff to build stuff with, right? So is anyone familiar with, well, first off, we all know different components, right? LEDs, solid spread boards, all that kind of good stuff, right? Okay. Has anyone ever heard of AliExpress? I love that store, right? We buy Arduinos by the dozens, mostly because some of them are broken when they get here. Most of them work, so it's a great store to buy things cheaply. Don't know. We were struggling with our internet connection, so I'm not sure if it's going to work. There it is. Oops. So this is one thing that we kind of started to play with. There's an Arduino sensor kit out there. If anyone's had an opportunity to check this out, it comes up with 37 different sensors of all various different sizes and functionality, I should say. But it's $11 shipped for free. You can't really beat that. So this is one of the things we kind of thinking about the different designs we wanted to do when we boiled it down to Bluetooth and our antenna, but we wanted to kind of explore what are the other options. So this is one thing that we purchased to kind of just play around with and see what's what. Oops. Interneting at a hacking convention, never a good idea. It's okay.
Notice how good he is, one-handed there, though.
Why do you got to go there? All right, so we can easily find Arduinos out here as well, pretty much any shape and size. Obviously, grain of salt, they are knockoff Arduinos. It's not the real thing, right? So obviously, understand what you're buying. I always recommend buying them in bulk, so that way, if one or two doesn't work, you're probably not going to get them. You might get them returned to China, but maybe not. Probably. So then we selected a couple of different Arduinos that seem to be the most popular ones out there. First off, the Arduino Nano. Has anyone ever played with the Arduino Nano? Yeah? Couple? Okay. It seems to be extremely popular. The main reason is it has a USB to serial adapter built in. It's got a separate chip for that. So it's really simple to program. The one reason I personally don't like the Nano is it has components on both sides. We'll talk about that in a little while, why we wanted it to be flat on one side. for the surface mounting. So that's why we went with the Arduino Pro. It's a little bit of a different chip design. You can still use it as, or you can still program it through USB, but it's a little bit more difficult. It does have another cool feature where it can actually emulate like a HID device. So it can actually use these to make other projects as well. So, anyone want to add to that? So, kind of already explained this, but why do we choose Arduinos? They're inexpensive, they're flexible, right? We can kind of solder them and mess them up and put them wherever we want to put them. And if we break one for $3, it's not that big a deal. Also, there's a huge community around sample code out there, right? So it's really, really simple to go out and find sample code. Because I don't really speak C, but it's not easy to do.
And one of the other main reasons we chose the Arduino is it's really easy to translate from prototyping using an actual Arduino board to building like a final product that just uses the bare chip. So every Arduino board has this bare at mega chip. There's different versions, but you can build your board around that chip. There's a few extra components you need. I've got those listed here. You can find that online. And it's a little more difficult to program when you go to the bare chip then, because it doesn't come pre-baked with the Arduino bootloader that lets you program via the USB. You actually need this other device I've got shown here, or a different variant of it called an ISP programmer. These USB ASPs, at least I think the genuine one runs about $10 and knockoffs run just a couple bucks. But that's kind of the next revision. The board you're going to see here that we've built still has the full Arduino chip on it because it's still kind of in a, we consider it a kind of development board now. You know, it's a programming testing tool, but you know we're thinking of the next revision that's then going to have the chip just on the board itself to make like a very final product type look. So then prototyping, multiple stages to get through that. You may have seen the solderless breadboard. Again, I love the Arduino Pro Micros, the Arduino Nanos, because they plug right into these solderless breadboards, let you start adding other components on pretty easily to test your basic circuits out. Definitely how I talked about testing each individual functionality, I'm testing that on this solderless breadboard just to say, okay, how does this antenna coil work? Let's do it here. How does this work? Let's do it here, to figure out, how I put the parts together, how we put the parts together. You might then step up to, they call this proto board, where it's a little more permanent solution when you solder it together. I don't have a picture of the back of this, unfortunately, but if you look at the back of this, there'd be just globs of solder everywhere. If you've ever done this, it's a little more challenging than you might think it is, because making connections with globs of solder doesn't really, form like clay. It kind of does what it wants sometimes. So for a simple circuit, this proto board works pretty well. When we get to something as kind of complex as all the components we've added on here, we skip this step. This is a little too complex to try and do in solderless, in the proto board circuit like this. So that's where you get into, okay, let's skip that step and let's start kind of designing a PCB, a printed circuit board. And if you're not familiar, that's just this stuff without any components on it is printed circuit board. So I'm going to do a quick demo here of Fritzing, which is the program I use to do that kind of circuit board design. So how many people have used Fritzing before? Okay, we've got a few. So hopefully this will kind of get people interested. It's, again, not that difficult. So this is a different board that we built for the CypherCon conference in Milwaukee. Their theme was Morse code. So we built a Morse code board that people could actually build at the conference. And so I thought that it's a pretty simple circuit. It's only got a handful of components. I thought it'd be a good one to show some of the features of Fritzing and how to use it. So the first thing is...
We do have some, by the way, but I'm not going to throw them out to the crowd because they are PCB boards and I don't want anyone to get hurt. If you're interested, let me know.
So the first thing is we wanted a custom shape on this one, and luckily enough, the fab manufacturer in China who you order these boards from, they don't really charge you more to have a custom shape. They just charge you by the size of the shape itself. So having a square this big or having this custom shape wasn't really much of a price difference. So we thought, yeah, let's do a custom shape. It's actually not that difficult to do a custom shape. You have to start with vector graphic. So we had used Inkscape to just create a bunch of, this is a bunch of rounded rectangles and ovals and squares kind of stacked on top of each other. So I just kind of made that, it's supposed to look like a Morse code keying device. Made that in Inkscape, saved it in SVG, and that's kind of one of the first steps in fritzing is to pull that background in. So you see that green background there is the actual board that we would be adding components to. Once you've got that background, fritzing has basically what they call layers. So if we start looking at some of the layers, and I'll turn them off so they make a little bit more sense. So the black stuff we see here they call is the silk screen on the front. So that's the printing that actually goes on the front. We printed Morse code, we printed this is where the LED goes, this is where the speaker goes. So we can turn off that layer, silk screen top layer. Other parts we'll see here then, we'll see through holes where people might put components. Here's the grid for those components. And then the lines between them are called traces or wires. It's basically the electrical connections. The yellow ones are the ones on the top of the board. The orange ones are on the bottom of the board. So that's kind of what we're working towards. Well, how do we build something like this? Fritzing has this big parts library, so we can go search it. Let's say we're going to search for an LED. And it's going to show us kind of all the LEDs it's got in stock. And this was a through-hole project. So I should have said that before. So a through-hole project, like this board, means the holes go through the board, and you've got like an LED with wires on it. You stick those wires through the board, and you solder on the back of the board. Other projects like the mag spoofer are the surface mount, which means the components are smaller. You set them right on top of the board, and you kind of solder them right to the top of the board. So that's the difference between through-hole and surface mount. We could do both of them in fritzing. This one's a through-hole design. And so since it's a through-hole design, I've got to find a through-hole LED. So if I mouse over this LED, we see that there are two little yellow squares, which tells me it's a surface mount. It's got two surfaces for mounting that LED. I'm looking through a through-hole LED, so that's this one. It shows, the two little through holes there down in the corner when I mouse over, which means that's the shape I want. We got to find a place to put this. We'll just put it there. So that's how we can place things. I'm going to get rid of that silk screen top layer again, so I don't have to look at it. But now we've got that piece placed. Now we need to make the electrical connections for it. So this square box needs to go to ground. Actually, I should have left that silk screen top layer up, because I know that this is ground right here. So I know this connection is going to need to go to ground. And this connection's going to need to go to, so let's say this LED lights up when we turn the power on. So that's going to be when I turn the power on at the switch here. All right. But you can see that those wires aren't going to be good. They're crossing other wires. They're making electrical connections. Well, fritzing can solve that for us by auto-routing those. So I'm going to set these and tell them that they should auto-route by just turning off Do Not Auto-Route. And then if I push this auto-route button and everything works as it's supposed to, now it auto-routed some other things too, because I didn't turn those off. But you can see it's created two orange wires on the back of the board for those two connections. They actually don't even go to where I set them to. They went to someplace more convenient. If we want to look at that a little better, I'm going to turn off the silk screen. I'm going to turn off the copper top layer, and I'm going to turn the board around so I'm looking at the back. So here's that LED I just added. You can see it created this trace that connects over to some other connection that already existed that goes on when the power goes on. And this trace goes over here to this is ground. And Fritz is actually pretty nice. If I click on one of these components, it's going to highlight every other component that's electrically connected. So I could trace that back and see, yep, it's definitely connected to the ground. This one, yep, it's definitely connected to when power's on. So that's another nice feature there. So that's kind of how we go about adding components. And there's a pretty big library. Like I said, the Arduino chip is and we'll do a small one. No, we'll do. What should we do? 320. So the Arduino chip should be a 328. We should be able to find one of those here. So there's an Atmega 328. So we could even, add an Atmega processor, and that's how that would, and then we, again, just electrically connect the individual pins to whatever parts it needs to be connected to. So that's kind of the process to, again, add components. Michael and I like to do when we build one of these is actually go through and take our time and kind of line up all the wires so they look nice. This is a very calming, therapeutic activity that I could just do for hours, like straighten wires. Yeah, it's very, very, very satisfying. But once you've done that, now you can export it. So we're going to go through the steps of exporting this, like we're going to ship it off to the lab in China to have it fabricated, and then I'll show you how we can kind of verify and test that it looks pretty good too. So exporting it is actually simpler than you would think too. I've done this through Eagle 2, which is a more professional program for doing this, and there's a few more steps involved, and so that made it a little intimidating again, but Fritzing really makes it easy. It's file, export, for production, extended Gerber, and it's just going to ask me where do you want to put this. We'll make a new folder here. So we're going to say, well, export to production and put all the files in that demo folder. So what that actually creates for us, if we go look at that folder, is a number of files. Each one corresponds to one of those layers we were looking at. So there's a file that's the contour, which is the outside shape of the board. There's a file for the copper bottom, a file for the copper top. And to you and I, the contents of these files are pretty meaningless. It's a vector instruction file. But it'd be definitely good to look at these files before we ship it off to see if it actually looks like what we expected it to. There's another program out there called View that lets us do that. Those are Gerber files, that's why it's called View. So I'm just going to go and open that up in View, load Gerber file. We'll find that folder. And if I open all of those, it's going to pop that board and all its layers right in. And it looks kind of messy in View so far because it doesn't really understand as well as Fritzing did. But we can use this to kind of peel it apart and understand it better, make sure it is what we want. So, this layer clearly is the outside shape, and the outside shape looks good. It's solid. I don't see any problems with that. This layer appears to be the top traces. So, again, this is raw, what's getting sent to the manufacturer. So this is a good chance for me to go and say, well, that's a pretty thin line there. Maybe I should modify where this wire goes so I don't have such thin lines in between because I don't like those. Square this one off. So I can see mistakes that I've made or things that I want to touch up. And I can go through each layer and kind of confirm that. So here's the layer with some of the holes and the copper on the back of the board. There's going to be a silkscreen layer there, so I can actually see, did the silkscreen line up where it's supposed to? Oh, here I think even though I've got the LED on the part, its label is actually off the part. I'd have to go back and fix that. So that's kind of what View does for us. It lets us kind of go through and confirm that every layer looks pretty good before we send it off to fabricate. But once we've done that, I usually take 3 or 4 times around before I actually get a set of Gerber files I'm happy with. Then you zip this up and it's ready to send off with your order to have these fabricated. So that was our demo. Not too much went wrong. And I'm getting a little ahead of myself. So you could also use Fritzing to, instead of send it off for fabrication, you could use it to create printouts to etch your own PCB. I've done this a couple times. Just a high level of the process is you get board that's just clad in copper, covered in copper, and you get some chemicals that dissolve copper. And then you get some paper. You can use a specialized paper or magazine, actually paper like colored glossy paper for magazines actually works. But you print on the paper, you iron the printer ink from the paper onto your board. That's the black stuff you see here. And then you drop it in the etchant to try and dissolve all the copper where the black stuff isn't. This is an example of a board where that was almost done, but I pulled it out too soon. But after you do that, then you have to wash off where the black is to expose the rest of the copper, drill the holes manually. It works, and a lot of people have done it for a lot of years. I skip this step now when we build something because it's so cheap and so fast to just have somebody in China build a printed PCB for me instead of going through all this effort, even if it's just 1 or 2 prototypes. But it still can be done. But that's when we get to kind of fabricating.
So now that I let Kevin do all the heavy lifting, I'm gonna get my hands dirty with keyboards. So now we get into the fabrication and design. As Kevin mentioned earlier, we had gone through a couple of different iterations of boards. I guess this would be version 3 that we're on right now. We went through several different antenna styles as well. So it was one of our other big prototyping challenges is what kind of antenna do we need? What size? How many wraps? How much power needs to be running through the antenna? What kind of range can we get, etc. So there was a lot of experiments around that. This is one of our earlier designs. We went with sort of like a diamond or a square shape to see if we could get a better range on that. And then eventually we figured out that it would work just as well if we had it flat and maybe a little bit wider. So that's sort of the design we ended up going with because then it fits a little bit nicer in a carrying case or in your pocket or something like that. The antenna doesn't get in your way. So these are just 2 examples of early prototyping. As Kevin mentioned, I think he's going to talk about some of the pricing later and how we actually had these prototypes so quickly. But instead of etching our own or doing the proto boards, we were able to have these fabricated from China using the same techniques that Kevin just showed us. And we had these relatively quickly. And they look a little bit clunky. They're obviously much bigger than the final product, but they were our first prototype. You already went over exporting and View stuff, so let's get that. Oh, ordering.
So now we're ready to order our device. And again, this was one of the things that was intimidating. Like, what am I going to screw up? How does this work? That I found was actually absurdly easy. We order a lot of stuff through PCBWay now, but I've used other houses out there as well, and I've had pretty much similar experience across the board. We use PCBWay. One of the reasons is because they have this deal. They've always had it for the last couple of years. That $5 for 10 boards to get you in the door. You'll find that 10 boards is actually $20. So, or 20 boards is actually $20. And we can actually see that here. No, not free shipping. So it's pretty easy though to figure out, okay, I've built this board and I know what size it is. What's it going to cost to have them print it and ship it to me? Let's say it's 50 millimeters by 50 millimeters, and we just want 10 of them. And the standard 2 layers. Two layers means we've got copper on both sides, which is pretty standard. And the 1.6 millimeter thickness is pretty standard. And as long as we've got some internet here still. We're having some internet issues. Yay, still working. Okay. But they've got a lot of choices for us at this point, but they're all pretty straightforward, and the defaults in most cases are just fine. The board type is a single piece. We're going to have them cut out the boards for us. There's just one design in our panel, so it's 10 of the same thing basically. We already told them the size and the number, the layers. We just want the standard board type. I don't even know what this means. I've never looked it up. You can choose different thicknesses, get a little thinner, a little thicker. It gets more expensive if you choose the outliers. You can choose a different track spacing. 6 mil is actually pretty small already. These get more expensive because they're very tiny traces and very much higher standards. Everything I've built that I can eye up, that looks like there's enough space there, has always been fine at 6 mil. Min hole size, again, that's 0.3 millimeter is smaller than any hole that we've created ever to date. So again, all the standards are pretty good. But it's even nice you can choose different colors of board, and that doesn't even change your pricing really. And as you can see, my pricing there is just $5 for those 10 boards, and then $21 shipping, which hurts a little bit. But if I were to try and etch these, that's probably an 8-hour process to etch just a few of them. Versus $21. And the other really awesome thing that just floors me every time is that, they show that this is DHL shipping you're paying for. That's the only choice you have. but they're fabricating it in 3 to 4 days, and then they're shipping it in 3 to 4 days. I've consistently had these on my doorstep like 10 days after I place the order. Like they're creating it in China, they're shipping it over, and there it is on my door in like less than 2 weeks, which just, it's crazy. You know, it annoys me because I'm always thinking like, if I had submitted an order 2 weeks ago, I'd have it today. But yeah, that's as simple as it is. It's filling up the cart like this. The next steps from here, you add this to your cart. When you pay for it, they have you attach those Gerber files, which you just attach your zip file. And then within a day, they'll open up that Gerber file, they'll look through it, and they'll get in touch with you if there's any issues, like, oh, this file type wasn't right, or these things overlap, you should fix this, we can't do this. So they do a quick quality check. They'll get back to you again within a day typically. And then you say accept, go, and 10 days later, these pretty cool, pretty cheap boards are on your doorstep. You can see this was what, $26 for 10 boards, so $2.60 a board for a batch of 10. But yeah, if we even go up to like 100, you know, $85. So 85 cents a board to get 100 of these on my doorstep in 10 days. It's crazy. The only caveat with ordering stuff from, challenge I've had with ordering stuff from China is to not order around the Chinese New Year, because it's not 10 days then, it's like 6 weeks and 10 days. They're just gone for 6 weeks, is what I found.
Of course, Kevin makes me put everything together. He says I do a better job, but I just don't think he likes doing it. So we just talked about outsourcing, which is not too bad. Obviously, we have our PCB created through PCB Way relatively cheaply. And now the task comes, for us at least, do we want to assemble these things ourselves? Because we've got, what, about a half dozen or so surface mount components on it. We've got a battery on the back, and have to wind the antennas. So it was a labor of love, let's say, to try to make this thing, to make it work. So the big question for us is, do we want to do it ourselves? We actually want to produce these at any particular scale, or do we want to have somebody else do it for us, right? How much cost do we want? So real easily, we already sort of talked about this, but we've got our PCB, our blank PCB on the side, on the left side, and then we have one with components. We've found that actually surface mount soldering is relatively easy, and I think it intimidates a lot of people. So hopefully, with a couple of tools, and after this talk, we'll encourage more people to start fires in their living rooms. Please don't do that. But the easiest thing for you to do is keep all of your components on one side. If you ever look at an embedded device like a router or whatever have you, you'll notice that there's a lot of surface mount components on both sides of a PCB board, right? If you want to do it yourself, that can be sort of disastrous. We started off with some early designs where we had multiple PCB boards kind of stacked on top of each other, where if you like this one, we've got the Arduino and the Bluetooth module. Well, those two modules came to us already pre-soldered with surface mount components on it. So if we wanted to surface mount that component onto our board, it would liquefy all the other solder of their surface mount components, right? So then it got extremely challenging. So if you've got components on both sides, you have to figure out how are you going to solder on two sides of a board, right? Which actually is a little bit more challenging than you think. So what we ended up doing is, because it's building stuff on a budget, this is basically what we came up with, is you need some kind of solder paste, right? And Quick Chip is fairly inexpensive, so $15. And yeah, that's that stuff right there. It comes in a little syringe. We actually got stuff with lead or lead-free, thank you, brain part there. We found that stuff with lead actually works better. Just, don't lick your fingers when you're done. You'll need an electric frying skillet. If you're going to borrow your wives or girlfriends or whoever's, just make sure you don't cook in it again. Because it is, well, leaded solder. I highly recommend a metal spatula. Don't try to use a plastic one, trust me. You're going to need some kind of aluminum foil, doesn't really matter what, and then I recommend a good set of tweezers. So we found like a jeweler set of tweezers works really well for $10 or something like that. So From AliExpress, of course. All in, I think we're like about $63-ish, right? Give or take, depending on how much you spend on each item. So, really simply, you preheat the frying skillet. While that's happening, you take your board. I don't think I brought any down with me. They're in my room. If anyone wants to see a bare board, I do have them. But basically, on all the pads, you take your little syringe of solder paste. It's actually solder and flux combined, so it's kind of like a toothpastey mixture. And you basically put little drops on each pad, extremely little drops on each pad, because a little drop goes a very long way. And then you take your tweezers and you sit there and you put all the components on, and then you decide that, that component's backwards, so then you flip all the components around, or you drop a component on crooked and you say bad words. What you want to do with the aluminum foil, what we found works really well, is you make a pad a few inches larger than the component that you're soldering. So it's, I don't know, maybe 6 or 7 folds of aluminum foil, and you're making a little bed for it to sit on. We found this really helps dissipate the heat and solders it much more evenly. So then you place the aluminum pad into the frying pan along with the component itself. And then, of course, magic ensues. As for some imagery for you, on the left-hand side, just raw pads. On the right-hand side, we actually have little dabs of solder. You'll notice how small the little dabs of solder actually are. We have seen videos of people being able to put sort of large globs of solder across an entire chip, like from left to right, but I did not have success with that. I spent a lot of time desoldering all the bridges that I ended up making. So this seems to work. It's a little bit more putsy, but it seems to work a lot better. And then, of course, we slap the components on. Again, on the left, we've got the raw components just sitting there on top of the solder with flux. And then after the soldering process, that's what they look like on the right. Oh, yeah. And I don't do demo fails, so I made a video. Mostly because I thought it was a really bad idea to bring in a hot frying pan and put something on stage, so I don't know. So that's just a real quick example of putting the solder paste on, putting the components up there. If you look right here at this chip, you'll notice it just starts to melt, and it just sort of wants to suck itself in, and it actually straightens the component right onto the pad. It's pretty nice. You'll notice the top capacitor there is going to do the same thing in just a moment. A little glob of solder is going to go away. And by looking at it, you're gonna know that it worked, because it's going to turn from a dull gray to a nice shiny silver, like you would expect copper. And again, on the chip right here, you're going to notice on the right-hand side, and there that goes. That's me stepping in front of the light because I'm smart. And then all the solder just gets sucked right up. So it's pretty nice. So as you're sitting there watching it, haven't found too much of an issue leaving it in the pan for an extended period of time. If it's sitting in there for an extra minute or two, it doesn't seem to damage any of the components, not that I've been able to tell. So that's pretty much it.
That was real time. That was just probably, 2 or 3 minutes per pan?
Yeah, so it takes a couple of minutes, obviously. What I do, again, I put the tinfoil pad in there, put the component onto the pad. I actually put the glass cover back on to retain some of the heat. Let it sit in there for a few minutes, and then all of a sudden you'll just notice after a few minutes of sitting there doing nothing, and you're thinking to yourself, is it going to happen? All of a sudden it just magic, and then all of a sudden they're all soldered. It's really cool.
What's the max temperature?
Good question. I measured it at about 500 degrees. I think it actually says 400 on the dial is the actual frying pan, but when I measured it with a thermometer, it said 500 some degrees. So.
You're just setting that flat on a few.
Yep, exactly. Yep. That was the video. If anyone is interested, the video is online. If you go to YouTube and Google the Mayhem Lab, you'll find us along with some other videos that we've done as well. But that's out there for you to enjoy. It's not as good as the last cat video we saw, but it's up there. Oh, yes.
So So then we thought, well, let's figure out what, okay, if we were ever to want to make like a professional product like this that we sell, we probably don't want to be, building in the skillet in the basement. What would it take? What does it look like to have, somebody fabricate this stuff for us? So we went with PCBWay again. They've got like a quote thing there for, what is it to actually have us assemble your device. But their quote isn't really realistic there because they have to do a lot of research and manual labor on the background to get you a real quote. So the process was I gave them the first designs and kind of my bill of materials, and they came back with a lot of questions, and they wanted a very detailed bill of materials. You have to tell them whether you're going to send them the components and the parts, or whether they're going to buy the components and the parts, and we thought, well, you guys should just buy the components and the parts because you know what's going to work for you. So there was probably a couple weeks of back and forth to try and get all that information worked out. And it wasn't like we could just give them the design and they give us the finished part. They actually wanted to see photographs of a finished part so that they could make sure that they're orienting the components the same way and all that kind of stuff. But once we got through all that, it cost us about $300 for this order for 20 assembled boards, which comes down to about $15 per each board, which is, outside our budget for kind of playing with stuff. But if we were to try and, make a product like this, you could definitely sell it for more than $15. And you can see how that broke down. They bought the part that wasn't very expensive. Most of that was in their assembly. And this was for them assembling 8 of the service mount components. When it got to us, we were adding other components and the antenna and stuff like that. And it took quite a bit longer as well. It wasn't the 10 days. It was probably about 4 weeks to get these on our doorstep. I probably would do it again, though, if we had a good finished design. I think it worked out well for us. But I find that the surface mount soldering is actually really easy because I just give stuff to Michael and he does it. So that's the presentation. We'll hang out here for a few minutes for questions. But also, I brought along a lot of the other stuff that we've kind of built over the last couple of years. I've got, what is this? This is a micro Makey. I don't know if anybody's familiar with a Makey. It's a little device that, it's like a toy you build, but the heart of it's an Arduino. So this is a little board that you can attach an Arduino to and attach some resistors to and make a Makey toy. This board is an RFID spoofer, so you attach an Arduino to it and a magnetic coil to it, and you can spoof like the card readers in like door card readers with the Arduino. This one is called an Atari Punk console. It's a little toy that makes noises. We've got the boards from CypherCon, and we've got some TTL USB to TTL adapters, so you can use these to program some of the Arduinos that don't have the USB header on them. So when we finish the talk, if you want to come up here and pick one thing off the table, go right ahead. If you're curious about a specific thing, just ask us and we'll try and point one. We thought if there's one left. When it's gone, it's gone. I'm sorry. There's quite a big pile here, though, so hopefully there's enough to go around for people who want stuff. And we've got cards here, too, so you can reach out to us if you have questions about how to build it, or it's just a... Oh, yeah, we'll put them on the site, too. Yeah. Okay. Any questions about the talk?